Welcome to this interactive explainer. Today, we're doing something kind of different, but honestly really fun. We're going to dive straight into an actual biology worksheet and decode the secrets of the plant kingdom together. So, if you love a good puzzle, you are absolutely in the right place. Let's get into it. Our source material today is literally the ultimate plant classification test. And you know what's so cool about this? This single document is just packed with clues about plant evolution. By following its strict question and answer format, we're going to tackle this whole thing like detectives solving a mystery. We're not just reading facts here, we're uncovering them by answering the exact questions right there on the page.
Here's our quick agenda for today. 1. Matching plant kingdom divisions. 2. Fill-in-the-blank plant facts. 3. Exploring phanerogams and seeds. 4. A focus on ferns. And finally, 5. The criteria for plant classification.
All right, let's kick things off with Section 1, Matching Plant Kingdom Divisions.
So, let's jump right into this first exercise. It asks us to link terms across 3 totally scrambled columns. Looking at the raw puzzle here, we've got column A with the scientific divisions, column B with their characteristics, and column C with examples. But hey, look really closely. You see those handwritten numbers mapping out the connections? Some awesome student from the past actually left us a trail of breadcrumbs, and that gives us our very first major clues to cracking this thing. Let's test this out with our first question. Which division mainly grows in water and matches with the example of algae? Take a quick second to look. If we follow that handwritten number 1 straight across the page, we find our answer just sitting there waiting for us.
The answer is Thallophyta. By connecting those dots, we literally just learned that the division Thallophyta represents aquatic plants, and the classic example given is algae. It's a perfect match, right?
Moving right along. What about the amphibians of the plant kingdom? We're looking for the plants that kind of bridge that gap between water and land. If we follow the handwritten number 2, let's see exactly where it leads us.
It leads us directly to Bryophyta, and honestly, this brilliantly illustrates why they're called amphibians in the first place. These plants absolutely need water, specifically for their reproduction, even though they live on land. Moss is our prime example here.
The rest of this matching exercise basically lays out the whole evolution of complexity in plants. Pteridophytes step it up by having dedicated tissues for conducting water and food. Think of the fern. Then we get to seeds. Gymnosperms have absolutely no natural covering on their seeds, like the cycas. And finally, angiosperms are the most protected of the bunch. Their seeds are formed safely inside fruits, beautifully shown by the tamarind.
Moving on to Section 2, Fill-in-the-blank plant facts.
Okay, so we've got the broad categories down. Now it's time to really put our botanical vocabulary to the test. Our first fill-in-the-blank question reads, blank plants have soft and fiber-like body. We've got a specific word bank to choose from: angiosperms, gymnosperms, spore, bryophyta, thallophyta, or zygote. Out of those options, which one accurately describes a soft, fiber-like physical structure?
It's Thallophyta. We already know this one, right? This perfectly describes the physical makeup of those water-dwelling plants, like algae, that we literally just decoded in the matching section. They don't have hard, woody stems. They're super soft and fiber-like.
Let's tackle a double blank question next. This one says, in pteridophytes, asexual reproduction occurs by blank formation, and sexual reproduction occurs by blank formation. Remember, pteridophytes are plants like ferns. So how exactly do they reproduce? Let's check that word bank one more time.
The really crucial takeaway here is that they actually utilize both methods. They rely on spore formation for asexual reproduction and zygote formation for sexual reproduction. This dual strategy is a huge defining characteristic of the pteridophyte life cycle.
Next up is Section 3, Exploring phanerogams and seeds.
All right, let's shift gears a bit and skip down to the short answer section of this worksheet. Question 3b poses a pretty classic botanical challenge. It asks us to distinguish between monocots and dicots. Now, separating these two is a huge deal in botany, but the document itself actually gives us a massive, massive hint about how to answer this. It's just hidden a little further down the page.
Take a close look at the project section at the very bottom. It tells students to prepare an album of monocot and dicot seeds. By prompting you to specifically collect and display the seeds, the text is practically shouting the answer at us. The fundamental difference between monocots and dicots lies right there in the seed structure itself. The answer was just cleverly hiding in the homework assignment all along.
That brings us to Section 4, Focus on Ferns.
Okay,
Question 3C asks us to write a paragraph, in our own words, about the ornamental plants called ferns. Now you might be thinking we need to go grab a textbook to answer this one, but nope. Based strictly on the question and answer puzzle we've already solved today, what are the defining traits of a fern? We can actually build a completely comprehensive paragraph entirely from the facts we just uncovered.
Let's just piece it together clue by clue. First, from our matching table, we know ferns belong to the division Pteridophyta. We also know they have specialized tissues present for the conduction of water and food. And from our fill-in-the-blanks, we know they reproduce asexually by spores and sexually by zygotes. You just string those individual facts together and boom, you've got a perfect scientifically accurate paragraph generated completely from the clues on the page.
Finally, Section 5, Criteria for Plant Classification.
We made it to the final section. Question 6 asks the ultimate overarching biological question of this whole exercise. Which criteria are used for the classification of plants? To answer this, we just need to look back at the entire worksheet as a whole. Think about the matching column. Think about the fill-in-the-blanks. What specific characteristics did this document constantly ask us to compare so we could tell these plants apart? The criteria for classification are literally hiding right in plain sight.
So here is the crucial takeaway. We classify plants based on 4 main criteria that we pulled straight from this worksheet. First, habitat. Do they grow mainly in water, like Thallophyta, or on land? Second, internal structures. Like, do they have conduction tissues like pterophytes? Third, reproduction methods. Do they use spores, or do they explicitly need water for reproduction like bryophytes? And fourth, seed protection. Do they have naked seeds like gymnosperms, or are the seeds safely formed inside fruits like angiosperms?
And that brings us to the end of our decoding session. By just following a simple question and answer format, we managed to unpack the entire structure of the plant kingdom. So I'm going to leave you with this thought. Now that you've totally mastered these classification criteria from a single piece of paper, how are you going to look at the plants in your own neighborhood or your own backyard differently? Which ones have naked seeds? Which ones have conduction tissues? The clues are everywhere, just waiting for you to classify them. Thanks so much for joining me on this explainer, and remember, keep questioning the world around you.